All right, so let's get started here with topic one. And in this topic one video, I am going to give you the two basic rules that we need in order to begin talking about how to take the derivative of trigonometric functions. And just like when you were in trigonometry, I'm assuming you weren't in my class, but I'm assuming you probably started to talk about trigonometry first with the sine function and the cosine function, because really everything else about trigonometry follows from the information we know about the sine and the cosine, the x and the y, or the y and the x, of the unit circle. So everything really boils down to what the rules are for sine and cosine, and it doesn't change when we start to talk about the derivative of trig functions. We still need to talk about sine and cosine first, so that's what we're going to do here in topic one. So in order to do that, let's switch over to this other page, and I'm just going to give you the rules as a starting point. There we go. So we have, we're looking to find a rule for the derivative with respect to x of sine of x. And we also need to decide or talk about the rule. We can't really decide, it's kind of already been decided for us. The derivative with respect to x of the cosine function. All right, you ready for this? It's so tricky. And I'm going to say it the way that I want you to say it in your head over and over and over again until it just gets stuck in there. So here's what it is. The derivative of sine is cosine, and the derivative of cosine is negative sine. So I'll say it again because that's our little chant, our trigonometry chant. The derivative of sine is cosine, the derivative of cosine is negative sine. And that's it. And actually, if you think about what the graph of cosine and sine look like, the fact that they're both just some kind of repeating periodic function, it kind of makes sense when you think that the slope of the sine function is the cosine function. Since everywhere that the sine function has a slope of 0, the cosine function has a position of 0. So actually, hold that thought. Let's go over here. I didn't actually think to make a graph. I could have done that, but we'll do it the easy way here. Here's the sine function. Just the first part of it, right? And the cosine function, we'll do it in blue, looks like that. There we go. I'm trying to make it as exact as possible. So notice that anytime that the sine function, which is in red, has a slope of 0, so that would be here, here, and then repeatedly throughout, from there to infinity in each direction, that is also where the cosine function, if I had it just where it's supposed to be, it zeroes out here, and it zeroes out again right here. So it actually makes sense when you start to think about why is the derivative of the sine function the cosine function? Oh, and we look at the graphs, it kind of does make sense. And then the derivative of cosine is negative sine for the same kind of reasoning. If you want something interesting to explore, you can feel free to draw that out in your graphing calculators and you'll see that they work. So that's it. Let's go back just so we can be thorough. Make sure they're written down. Derivative of sine is cosine. The derivative of cosine is negative sine. Let's look at an example of how to use that. I have two interesting examples for us. So the first one is going to be this. Example 1 is y equals x squared times sine of x. The reason I'm using this equation as our example, we're going to find y prime, is because it incorporates some of the rules we learned in prior sections about the product rule, right? So if you notice, what we have here is a u and, what other color can I use? We'll use purple. And a v. And if we have u times v, we can use our product rule. And let's set that up and see what happens. So we'll say we're going to use the product rule because we have two functions that are being multiplied. u is x squared, as we already said, and v is sine of x. So we want to find u prime. Well, we use the power rule, bring the 2 to the front, drop the power down by 1, so it becomes 2x. And then v prime, we just use our little mantra that we have in our head. The derivative of sine is cosine. The derivative of cosine is negative sine. So here we have sine, so the derivative, v prime, is cosine. And let's use our rule. U v prime plus v u prime. Or actually, sorry, I like the way that we did it in class better. We did v u prime plus u v prime. Gives you the same answer, but okay, let's write it down. I'm going to do it in a different color because I want to go back to green. So v is sine of x. U prime is 2x. Keep in mind that that 2x is not inside the sine function. So just that's like 2x out front or outside of sine x. Plus u v prime. U is x squared. V prime is cosine of x. So if I kind of write that out in a slightly more just easy to read way, I would write it as 2x sine x plus x squared cosine of x. And we can't simplify that because we can't combine sine and cosine, and can't combine, or we don't need to pull out an x or anything like that. So that's it. That's how we do it. So that's example 1. Just for good measure, let's do a second example. Clear that out. Feel free to rewind if I just cleared that too quickly. And we'll do example 2. And we'll make y equal to cosine of x over 1 minus sine of x. All right, so if you take a second, look at this problem and think, what kind of problem is this? Are we using a product, or are we finding a product, sorry, or are we finding a quotient? And we'll see here, we're dividing. So this is going to be a place where we want to use the quotient rule. On the top is our u, and on the bottom is our v. So we'll say u equals cosine of x, v equals 1 minus sine of x, and then we find our u prime and our v prime. We go back to what we know about sine and cosine. Derivative of sine is cosine. Derivative of cosine is negative sine. So in this first portion here, u equals cosine of x, the derivative of cosine is negative sine. In the second part, v, 1 minus sine x, we know that the derivative of a constant is just 0. So we can kind of ignore 1 a little bit. Not that we're crossing that out. Sorry, I shouldn't actually do that because we need that. But we don't need to take the derivative of it because it's 0. We just want to take the derivative of negative sine. So let's ignore the negative. We know the derivative of sine is cosine. Therefore, the derivative of negative sine would be negative cosine, because we know that the way that derivatives work, we can pass that negative on. If we had 2 sine of x, the derivative would be 2 cosine of x. So if we have negative 1 sine of x, then our derivative is negative cosine of x. Okay, now we have all of our information. We just need to plug it into what we know about the quotient rule, which is v u prime minus uv prime all over v squared, which is probably, you're getting used to that by now. We've done that enough times. So plugging it in, we get 1 minus sine of x is v times u prime, which is negative sine of x. I can tell I'm going to run out of room here. Maybe I should, well, we'll try to fit it in. Minus u, which is cosine of x, times v prime, which is negative cosine of x. I am going to rewrite this later. Maybe I'll write it. I'll find a way to write it. We'll work with it. All over v squared. So that would be 1 minus sine of x squared. Let me go to, sorry, you won't be able to see my face here for a second, but I'm just going to give us a blank screen and I'm going to rewrite that at the top. So you have it on your page, but I'm going to write it more neatly because I want us to go through the process of simplifying it. Minus cosine of x times negative cosine of x all over, oh my goodness, 1 minus sine of x all squared. So this first section, 1 minus sine of x times negative sine of x, we can simplify by multiplying that negative sine x to each term here. When we do that, negative sine x times 1 is just negative sine of x. Negative sine of x times negative sine of x is plus sine squared of x. And then in the second one, we're just multiplying negative cosine of x times negative cosine of x, which gives me plus cosine squared of x. Now, I'm not going to tell you exactly what I'm going to do here yet, but while I go and simplify the denominator, think about, actually, you know what? I am not going to simplify the denominator. I'm just going to rewrite it. So think for a second while I rewrite it. What do we know about sine squared of x plus cosine squared of x? Do you remember anything about that from trigonometry while I rewrite this here? I was going to simplify it, but I'm looking ahead and thinking I might save myself some work if I don't. Okay, so there is our answer, except if you remember back to trigonometry, we had this wonderful identity, which is probably the most useful identity in trigonometry, which says sine squared plus cosine squared is equal to just 1. Now, just in case you don't remember why, remember that the unit circle shows us, here we go, that any point on the unit circle, the y value is really sine, and the x value of that point, of the location of that point, is cosine, right? So I'll just say, darker color here, S for sine and C for cosine. We also know that on the unit circle, the radius is always 1. And so from what we know about the Pythagorean Theorem, if we square the two legs, we get the square of the hypotenuse. So what we really have here is the x value, in other words, cosine squared, plus the y value, sine squared, equals 1 squared, right? The hypotenuse squared, which here, I'm wearing blue. That's going to make that confusing. What can I do? I'll write it in pink. Equals 1. So the x squared plus, or the one leg squared plus the second leg squared will always equal 1. And so just in case you didn't remember that, cosine squared plus sine squared of x always will equal 1, and it's still a useful trigonometric identity that you don't want to forget. Keep that tucked away. So hopefully that reminds you of why. Let me clear that off. Going back to our answer here. We can just turn this whole expression, sine squared of x plus cosine squared of x, into 1. And what we get as our numerator of this function is negative sine of x plus 1, which is really just 1 minus sine of x, right? Negative sine of x plus 1 is the same as 1 minus sine of x, all over 1 minus sine of x, sine of x squared. Well, we can cancel that. Basically, that means we have 1 minus sine x at the top, and we have 2 products, or 2 factors of 1 minus sine of x on the bottom. So we can cancel the one on the top and one of the ones on the bottom. And the answer ends up being just 1 over, I'm just going to write it here, 1 over 1 minus sine of x. That's it. We go back to y. Look down here in the corner. We had 1 minus sine of x on the top, 1 minus sine of x squared, and we cancel out, and this is our derivative, y prime. So we took up like 3 screens trying to write that out there. All right, those are your 2 examples, example 1 and example 2. Example 1 was a little bit easier because we didn't have anything to simplify, so we just plugged it into our formula, got out our answer. The second example, we still just took a formula, plugged in the answers, but I wanted to show you that example as a reminder that things like trig identities are still important, because thinking about 1 over 1 minus sine of x and how nice and neat that looks, and then comparing it to what we had here at the end of plugging into the formula, that was just crazy looking. So it does pay to simplify. It makes your answer look a lot nicer. All right, so that's it for topic 1. In topic 2, I'm going to give you the rest of the trig, the basic, well, I should say you could call it more advanced. What do I call it, more advanced? Yeah, I call it more advanced, but they're not really more advanced, they're just 4 more. So we did sine and cosine. Now we're going to talk about tangent, cotangent, secant, and cosecant. And then we will be done.